Welcome. In this video, we are going to find some value k that makes this function continuous. And in order to do so, let's recall what continuity actually means. This function h has to be defined at k. This limit as x approaches k of h of x has to exist, and these values have to be equal to each other. So let's begin, and let's start by setting these two equal to each other to ensure we can find to ensure they're at the same value at k. Let's begin by setting these two equal to each other to ensure we have the same value at k. And solving algebraically, we end up with x equals -5. So this tells me as long as k equals -5, this linear equation and this linear equation will connect at that point. That's when k equals -5, so when x is -5, and this will ensure this function is continuous. And now to double check, let's check the limit portion of continuity. So let's check as x approaches -5 from the left of h of x, and the limit as x approaches -5 from the right of h of x. And so of course we're saying this is -5. So if we're approaching from the left-hand side, that means we want values that are smaller than -5, so that's here. And -5 does lie in this domain, so we can just apply direct substitution to get -15 plus 2, or -13. Now let's go ahead and evaluate the limit as we approach -5 from the right-hand side. Now that we're done from the left, and this is the limit as x approaches -5 from the right of 2x minus 3. And again, applying direct substitution, we get 2 times -5 minus 3, or -13. Since these two left-hand and right-hand limits coincide, we know that the limit as x approaches -5 of h of x equals -13. And now, h of -5 is equal to, and that when we are equal, we are here. 2 times -5 minus 3, which is just -13. So now we've shown that the limit exists, it equals this value, this function is defined, and it equals the same value. So now h is continuous. I hope this video was helpful.